Hi everyone, welcome to day 4. If you could be putting day 4 in your planners. Also have your homework out so it's ready when it's time to go over it. And you do have a warm-up today as well. So we're going to pause the video for 3 minutes for you to be able to have that written in your planners, have your homework out, and complete the warm-up in that time. If you're stuck on the warm-up, ask someone nearby to help you out with it. All right, so they tell us we have a square. So let's draw a square. They told us the diagonal is 18. Well, things that we know about a square, all the sides are the same. We know all the angles are right angles. So those triangles, because the sides are the same, it would be an isosceles triangle. The only way to be a right triangle and be isosceles is if we have a 45, 45, 90 triangle. So we want to think our 45, 45, 90 and our D's from that. So we'll have D, D, and D square root of 2. So first step we always do is take the numbered side they give us, 18 in this case, set it equal to what we have from our D's, so equals D square root of 2. Next we'll solve for D, so divide both sides by square root of 2. We get 18 over square root of 2 is equal to D. We need to rationalize that by multiplying top and bottom by square root of 2. We'll get 18 square root of 2 over 2 for D. Divide the 18 into 2, so you get 9 square root of 2 for D. Well, that's our other sides because they were just D, so we get 9 square root of 2 for each of them. Well, that's not what the problem wants. It wants the area of the square. Well, area of the square, you're just doing base times height, but they're both the same. So we're going to do 9 square root of 2 times 9 square root of 2. Well, let's multiply the 9's together. We get 81. Square root of 2 times square root of 2 just gives us 2. So this is just going to be 162, and it's an area, so we should say units squared. If they had given us centimeters, we would say centimeter squared, inches, inches squared, so on. They didn't give us that, so they would say unit squared for the area. So you can stick your warm-up away. We'll flip over to the homework. So, letter A, we want to recognize we have a 45, 45, 90 triangle. So take the side that they give us, square root of 2, set it equal to what should be there in terms of D. For us, that's just D. So now that we know D is square root of 2, X just has to be square root of 2. And Y should be D times square root of 2. So when you fill that D in there, it just gives you square root of 2 times square root of 2, which is 2. In B, we should recognize 45, 45, 90. So take the side that they give us, 15 square root of 2, set it equal to what's there in terms of D, D square root of 2. Divide the square root of 2 on the right over, you get D is 15. Well, from the 45, those should both be D, so X and Y are just 15. Going over to C, notice those sides are the same, meaning the angles are the same. So this is a 45, 45, 90. Identify your D. This side is just D, this is D square root of 2, so D is just square root of 5. So to find our missing side there, we would do square root of 5 times square root of 2 to just give us square root of 10. They give us 30, 60, 90. Across from 30 should be D, 60 should be D square root of 3, and 90 should be 2D. Remember, for your quiz and test in this unit, you will have to have that memorized. That's something you'd likely want to write right on the top of your quiz or test when you get it. So take the one that we have a number for. So 2D is equal to 2 square root of 3. Divide to get D by itself, so D is just square root of 3. So that means this side is just square root of 3, and this side will be square root of 3 times square root of 3, which is just 3. So square root of 3 for X, 3 for Y. In E, we've got our D across from the 30, D square root of 3 across from 60, and 2D across from 90. So take the number that we have, it was just d, so that's 12. So this one should have been an easy one. Just fill in your 12 for the d's. You get 12 square root of 3 for y, 24 for x. We've got our d square root of 3 across from 60, d across from 30, 2d across from 90. Take the number they gave us, 9 square root of 3, set it equal to the d square root of 3. Divide this square root of 3 over, you get d is 9. Fill it in, we get 9 for x and 18 for y. This one is sometimes tricky. People have trouble drawing the picture. So you have 4 helicopter blades meet at right angles. So basically that ends up looking like a crisscross. The distance between the tips of 2 of the blades is 36. So if we connected those, we get 36. Well, if they were all the same length helicopter blades, that makes this an isosceles triangle. So it's a 45, 45, 90 triangle. This one should be d square root of 2. So set up 36 equals d square root of 2. We'll work to get d by itself. Eventually we get d is 18 square root of 2. So that would be each of the helicopter blade lengths, and they want it to the nearest tenth. So when you type in 18 square root of 2, we get 25.5 feet. We've got a picture of an escalator here. We've got 30. This would have to be a 90, making up here would be 60. So this is d square root of 3, this is 2d. Well, we've got d is equal to 25, so the length of the escalator, 2d is just 50 feet, double that. We have multiple triangles in these pictures. The left-hand one, we have 90 and 60, so top is 30, 45, 45, 90. Start where we have a number. So across from this 90, this should be 2d. Now, we have D in the problem, so we would want to just use a different letter. I chose to use M instead of D. D doesn't happen in pictures too often, that's why we use it for all the other ones. So 2M is equal to 4 square root of 3, so M is 2 square root of 3. So that means across from 30 should be 2 square root of 3, that's our value of C. Across from 60, that's D square root of 3, so we'll take our 2 square root of 3 times square root of 3. Square root of 3 times square root of 3 is 3, and 2 times 3 is 6. So this is now 6. We'll now work with the 45, 45, 90 triangle. If that's 6, across from the other 45 is 6, and then this would have to be 6 square root of 2. That essentially becomes like our new M, or new D in that case. In B, across from the 90 was 10 and a 30, 60, 90. So I called that 2M instead of 2D because D is, again, the problem. So M is 5. So that makes this side be 5 square root of 3 and this side to be 5. We'll now work in the new triangle. Here's our 30. This was 5 square root of 3. So this would be double it, 10 square root of 3. And this side here would be 5 square root of 3 times square root of 3 because it's normally a D square root of 3. And that would end up giving us 15 eventually. So these double triangles, those are definitely more challenging ones. The ones like A through F, those are more average difficulty level. All right, we're gonna be on page 21 today. We might need our calculators a little bit, so please have those out. Today we are going to introduce something that you will use the rest of your math careers. So because you'll use it in every course from here on out in your math careers, you'll probably end up using what we learned today over 1,000 times in the rest of your math careers. So we've got a right triangle here, ABC, and we want to name the side that is opposite A. If you start at angle A and go straight across the picture, your opposite side would be CB. So here we're going to just write CB, and you could call it CB or BC. The side that is opposite B, we go straight across the picture, okay, traveling right through the middle, and opposite B would be AC. And then opposite angle C, well, C is the right angle. The side across from the right angle has a special name. That's the hypotenuse. So across from the right angle is always the hypotenuse. A vocab word that might be new to you that we'll use a lot today and going forward is the word adjacent. Adjacent just means next to. When we say adjacent, we mean next to, but not the hypotenuse, because we automatically call the one side the hypotenuse. So if we want the side that is adjacent to angle A, well, here's angle A. There's two sides that are adjacent to it, two that are next to it. Well, the AB is already called the hypotenuse. So therefore, we would consider AC to be the adjacent side to angle A. If we move down to angle B now, from angle B, there's two that are next to angle B, those two sides. But again, AB is already considered the hypotenuse, so we would consider CB to be the one that is adjacent to angle B. The first step in what we're going to learn today is being able to identify the opposite and adjacent sides from an angle and also knowing what the hypotenuse is. So down on the bottom here, the left-hand one, we're saying, okay, let's do it in relation to angle A. Well, from angle A, CB would be the opposite, AB would be adjacent, and AC has to be the hypotenuse because it's across from the right angle. But if we went in relation from angle C, our opposite is now AB, our adjacent, the one next to that's not the hypotenuse, is CB, and then the hypotenuse is AC. So it all depends which acute angle you are in relation to. So moving over to the next page, from the marked acute angle, we're going to label which side would be hypotenuse, adjacent, and opposite. We'll abbreviate the hypotenuse with H, we'll abbreviate the adjacent with A, and we'll abbreviate the opposite with O. So, in letter A here, hypotenuse is across from the right angle. So this has to be the H. Notice we're going from angle M. So the opposite, you go straight across the triangle. So this is our opposite. And then the adjacent is the one that is next to, but is not the hypotenuse. In question B, the hypotenuse is across from the right angle. Notice we're going from angle D here. The opposite goes straight across, and then the adjacent is the one that's next to, but is not the hypotenuse. We are going to pause the video for 1 minute to let you do those other three, C, D, and E. All right, hopefully we had LJ was hypotenuse, KJ was the opposite because it was across from the marked acute angle, and then LK was adjacent. In D, AC should have been hypotenuse because it's across from the right angle. From our marked acute angle, this should be opposite because it's across from it, and then the one that's adjacent or next to it but is not the hypotenuse is AB. And then the last one, E, hypotenuse is across from the right angle. Opposite our marked angle I would be GB, and then this would be the adjacent because it's next to but not the hypotenuse. All right, down on the bottom, in any right triangle, when you're given an angle measure, the ratio of the sides is going to be the same no matter the length of the sides. So what's meant by that is if you have, say, a 40-degree angle in your right triangle, the opposite over the hypotenuse side will always divide and reduce to the same thing, regardless of what the side lengths are. This is true in our special right triangles, which is why we had the D's, but it's also true in any right triangle. So there are three ratios for this year that you will have to know. They are called the sine, the cosine, and the tangent. Sine gets abbreviated with SIN. And it's the ratio of the opposite side over the hypotenuse. Cosine, we abbreviate as COS, and we read it as cos. And that is the ratio of the adjacent over the hypotenuse. And then lastly, tangent, we abbreviate as TAN, and we read it as tan. that's always the opposite over the adjacent. So if we go to the next slide, here is that in shorthand and a way to help remember it. So we have SOHCAHTOA. So what this stands for, this is for sine, O is for opposite, H is for hypotenuse. C is for cosine, and that's saying that you should do the adjacent over the hypotenuse. Oops. And for tan, we should do the opposite over the adjacent. So another way you can write it, and I kind of like this down here for our SOHCAHTOA. S stands for sine, and it's saying you'll do opposite over hypotenuse. Cos is for adjacent over hypotenuse, as tan is opposite over adjacent. So what I'd like you to do is let everyone flip to the back of the packet, and I write right where your special right triangles are from before. I'd like you to write those two blue things on the very back of your packet. So we're going to pause the video for 1 minute for you to write both of those in the back of your packet. So today we'll practice using these ratios. So going to the next slide, we've got a triangle and they gave us all the sides. So I'm going to write right on top here, so we have it. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And SOHCAHTOA is the little saying to help remember that. Now you need to know how to spell it or else it's useless. SOHCAHTOA. So we want to do sine of A. So that means A is our reference acute angle. And for sine, we do opposite over hypotenuse. So from A, our opposite is 12, so we'll put 12 in the numerator. Our hypotenuse is here, so we'll put 13 in the denominator. And that's it. Sine of A is just 12 over 13 because it is the opposite side over the hypotenuse side. And it's all in relation from the angle they tell you. Well, now we're going to do cos A. So we're still going from A. We can actually use what we did on previous stuff. We know this is opposite from A, that's adjacent, and this is hypotenuse. So from A, we just want to do adjacent over hypotenuse. Well, that's just 5 over 13. And that's it. That's our cosine ratio for angle A. Now, if those reduced, you could always reduce them, but neither of those reduce. Oops, I guess we're still going from angle A, so we could have left our O, A, and H here. And tangent is opposite over adjacent. So our opposite from angle A is 12 over our adjacent, which is 5. And that's it. So tangent is just 12/5 from angle A. Well, it's all in relation to which acute angle you are working from. So in these bottom ones here, they now want us to go from angle B. So from angle B, let's label the opposite, adjacent, and hypotenuse. So cross out if you had the ones written from angle A. So straight across, this is our opposite. The adjacent would be here, and the hypotenuse would be there. So sine from B, sine should be opposite over hypotenuse, so we'll have 5 over 13. Cosine from B, that should be adjacent over hypotenuse, so we'll have 12 over 13. And then tangent is opposite over adjacent, so we'll have 5 over 12. So one is just knowing the spelling of SOHCAHTOA, and then just picking out the opposite, adjacent, and hypotenuse sides from the acute angle, and then putting in your ratio. Moving over to number 3, we've got all 3 of our sides labeled in the right triangle. We're going to start from angle U. So here's U. From U, this is the opposite, this is the adjacent, that's the hypotenuse. Let's write out our SOHCAHTOA, SOHCAHTOA. First, we're doing cos of U. So cos should be A over H. So from angle U, the A is 24, and the h is 25. So we just get 24/25. From u, the tan is opposite over adjacent, so we'll have 7/24. And then from u, sine is opposite over hypotenuse, so we'll have 7/25. On the bottom, we're switching angles, so we need to erase our OH and A because that's going to switch up some. The hypotenuse always stays the same, but so from Q, this is now opposite because it's straight across the triangle. This is our adjacent because it's next to but not the hypotenuse, and this is the hypotenuse. So from Q, sine should be O over H. Well, that's just 24/25. Tan should be O over A, so that's 24/7. And cos is A over H, our adjacent over hypotenuse, so that's 7/25. So it's all dependent on which acute angle you are working from, and then just knowing your SOHCAHTOA. All right, let's look at one that has some sides that aren't necessarily as nice. So let's maybe do all the angle E ones first. So from angle E, going straight across, this is the opposite, this is the adjacent, and that's the hypotenuse because it's across from the right angle. We'll write out our SOHCAHTOA. So cos should be A over H. So we will just have 4/7 from angle E. For tan from angle E, we should have O over A. So that'll be square root of 33/4. And then sine is O over H. So we'll have square root of 33/7. We're now switching to angle D. So we've got to relabel our O's and A's. H will stay the same. But from D, this is now our O. That's our adjacent, our next to, but not the hypotenuse, and that's our H. So make sure you switch those because we're now at a new angle. So tangent is O over A. So we're going to have 4/square root of 33. But we have a square root in the denominator. So we have to bring something in from day one of this unit. Day one and day two we saw it. We can't have a square root in the denominator, so what we do is we multiply top and bottom by that square root. This process is called rationalizing the denominator. We'll get 4/square root of 33 in the numerator. And then the denominator, any square root times itself, we've seen is just the number. So that's just 33. So we get 4/square root of 33 over 33, and that's our tangent in simplified form. And those are going to be the trickiest ones. If you have a square root on the bottom, got to multiply top and bottom by that square root to get that square root out of the denominator. Those ones have a little extra work. Sine from D, we're just opposite over hypotenuse, so we have 4/7. And cos from D, we have A over H, the adjacent over hypotenuse, so that's square root of 33/7. Now, one thing to note that will come into play later in the unit, notice that the cos from D is equal to the sine from E, and that the cos from E is equal to the sine from D. So cos from one acute angle equals the sine from the other acute angle, and vice versa. All right, so another one here. Why don't we do all of the angle X's first? So from angle X, we have opposite, we have adjacent, and a hypotenuse is across from the right angle. So we have our SOHCAHTOA. Sine from X, opposite is 1, hypotenuse is square root of 10. Uh-oh, we can't have a square root in the denominator. So multiply top and bottom by square root of 10. That'll give us 1/square root of 10 on top. It's up to you if you want to put the 1 out front. You don't have to because it's multiplying. And then square root of 10 times square root of 10 is just 10. So we end up with square root of 10 over 10. Let's go down to the tan x so we can work off of the ones we labeled for angle x. Tangent's opposite over adjacent, so we would just get 1 over 3. And then going down to cos x, cosine's adjacent over hypotenuse, so we'd have 3 over square root of 10. Uh-oh, again, we've got the square root in the denominator. So multiply top and bottom by square root of 10. So that'll give us 3 square root of 10 in the numerator and just 10 in the denominator. Let's switch things up and work with from the acute angle y now. So here's y, going straight across the triangle for y, that's our O. Next to y, but not the hypotenuse, that's our A, and this is still our hypotenuse. So cosine is A over H. So we would just have 1 over square root of 10. And we know we have to rationalize that. And it shouldn't be a big surprise. 1 square root of 10 is square root of 10. Square root of 10 times square root of 10 is just 10. Tan from y is opposite over adjacent, so we'll have 3 over 1, and that just reduces to 3. And then sine of y, O over h, opposite over hypotenuse, is 3 over square root of 10. Again, we can't leave that square root in the denominator, and it shouldn't come as a big surprise because it's the same as the one below. We get 3 square root of 10 over 10. All right, moving over to question 6. They tell us sine from angle E is 3/5. Okay, so we're going from that angle. What we want to think about in our SOHCAHTOA is what sides are we working with? Sine is opposite over hypotenuse. Well, here's our O, because it's straight across. Here's our A, because it's next to, but not the hypotenuse, and here's our H. If they said sine is 3/5, that means it's our O over our H. So we can label the O side, the opposite side from E, 3, and we can label the H side 5. But we're still missing one side. This is a right triangle. Whenever you have a right triangle and you have 2 of the 3 sides, you can do Pythagorean theorem. So we're going to do our a squared plus b squared equals c squared. Remember, the c always has to be the hypotenuse. So we're going to do x squared for ED because we don't know it, plus 3 squared equals 5 squared. This will be x squared, 3 times 3 is 9, equals 5 times 5, which is 25. We'll subtract the 9 over, and x squared will give us 16. To undo a squared, we do a square root. So we'll have x equals, you might know what times itself is 16, or if you did menu number factor, that would be 2, 2, 2, 2. You'll have 2 pairs of 2's out front, nothing inside, so this is just 4. So that means our missing side is just 4, and a 3, 4, 5 right triangle is one that comes up a lot in math because they're small numbers and it works out nice. For 7, we're going to be working from H. So this is our opposite, that's our adjacent, and that's our hypotenuse. We're working with tan, which is O over A. Well, our O, that means, is 24, and our A is 7. We'll do Pythagorean theorem to find the hypotenuse. We'll have 7 squared plus 24 squared equals x squared. This is 49 plus 576 equals x squared. Or 625 equals x squared. Take the square root of both sides and we get 25 is equal to x. So that's our missing side. We'll do 2 more of these quick to finish off. So we're going from L. So from L, this is our O, this is our adjacent, that's our hypotenuse. Cosine is adjacent over hypotenuse. So this is A over H. So this is square root of 17 here, and the H is 9. To find the other side, we're going to have square root of 17 squared plus x squared equals our hypotenuse squared, which would be 9 squared. When you square a square root, they just wipe each other out, because this is really saying square root of 17 times square root of 17. So that's just 17 plus x squared equals 81. Subtract the 17 over, we'll get x squared is 64. And when we take the square root, we'll get x is 8. You could either type that in the calculator to figure out it's nice, or that's really 2 times 2 times 2 times 2 times 2 times 2. You have 3 pairs of 2, so 2 times 2 times 2 out front, that gives you the 8. And our last one, we're going from angle M. So from M, going straight across, this is the opposite. This is the adjacent, that's the hypotenuse. Sine is opposite over hypotenuse, so this is our O over our H. So we'll label the O side 5, the H side 6. And we need to find MN, so we'll do Pythagorean theorem. We'll have x squared plus 5 squared equals 6 squared. That's x squared plus 25 equals 36. If we subtract the 25 over, we get x squared equals 11. And if we take the square root, we'll get x is square root of 11. If we do menu number factor, we just get 11 back. So that doesn't simplify at all. So mn is just square root of 11. And some of these are going to come out just as square roots, and that's the best we can do. You should never be giving a decimal answer for those sides. Okay, leave it in simplest square root form if you have to. That's it for this video. You got day 4 homework, and have a great rest of your day.